Just a quick note before we get started, this video is part of our Mathematics and Statistics module in our FE Review course. If you would like access to the complete module right now, as well as other FE Review modules, a practice exam, and live Q&As, make sure to go to the link in the description and go to our FE Exam Academy. Once you go to the link and join, you'll have access to our full support in passing your FE exam. If you find this video useful, make sure to leave a like and subscribe to the channel for future updates. That being said, let's go ahead and get into today's topic. Hello, welcome to the next part of single variable calculus in the Mathematics and Statistics module. In this part, I'm just going to cover a few problems on L'Hopital's rule. So this first problem that we have is going to be limit as x approaches 0 of x squared over sine of x. We can do what we were doing in the initial set of limits problems and plug in x approaching 0 into this fraction here. 0 squared over sine of 0, which is going to end up being 0 over 0. Now this is where L'Hopital's rule comes in. So L'Hopital's rule is going to be a technique that we can use when the limit of a fraction like the one we have here gives us an indeterminate form, either 0 over 0 or infinity over infinity. Over on the FE reference manual, we actually have a section on L'Hopital's rule. It's on page 47. So here it says if a fractional function assumes an indeterminate form, which is one of these two, the limit will then be equal to one of these expressions. So it's either going to be the limit as x approaches the original value of f prime of x over g prime of x. And what it says here with the second derivative and third derivative, it's basically indicating that if we take the first derivative of the top and the bottom and it still gives us an indeterminate form, we'll just take the derivative again until we basically get something that is not indeterminate. So in this case, we have an indeterminate form of 0 over 0. So what we can do is we can use L'Hopital's rule like we saw in the reference manual, take the derivatives of the top and the bottom functions in the numerator and denominator. That'll give us 2x. The bottom one is going to be cosine x. And then now we can plug in our limit as x approaches 0. That is going to give us 2 times 0 over cosine of 0, which is then going to be 0 over 1. And the final result will be 0. So then if we take a look at the multiple choice, the answer is going to be C. So as you can see, we applied L'Hopital's rule because we had an indeterminate form 0 over 0. And in order to apply L'Hopital's rule, we took the derivative of the numerator and the denominator and then evaluated the limit and finally got something that was not indeterminate, which was our result of 0. Moving on to number 30. Now we have our limit as x approaches 1 of this fraction right here. As you can already tell, if we just plug in the limit as x approaches 1, we're going to end up with 1 minus 1 over 1 minus 1. That is going to give us 0 over 0 once again. And because this is indeterminate, we will apply L'Hopital's rule. So in this case, the derivative of the top part is going to be 3x squared. And then the derivative of the bottom part is going to be 2x. If we plug in 1, we're going to end up with this, and that is going to give us a result of 3 over 2. Therefore, the answer to our multiple choice is going to be A. Moving on to number 31, this is just going to be one last problem where we can use L'Hopital's rule. So as you can see, if we just plug in our limit as x approaches 0 to this equation, we're going to end up with sine of 0 minus 0 all over 0 cubed. And that is going to give us 0 over 0. So we'll practice L'Hopital's rule once again by taking the derivative of that denominator. So in this case, it'll be cosine x minus 1. And then the derivative of the numerator is going to be 3x squared. However, as you can see, once we plug in our 0, the result is still going to give us 0 over 0. So what that means is that we need to apply L'Hopital's rule again and see what we get. So now let's go ahead and take the derivative of the numerator and denominator once again. And we're going to end up with negative sine of x all over 6x. Once we plug in our x approaches 0, we're going to end up with 0 over 0 once again. So that means that we need to apply L'Hopital's rule one more time, and then this time it should give us a form that is not indeterminate. So let's see, we'll take the derivative of this. It's going to give us negative cosine of x. And then for the derivative of the bottom, we're going to end up with 6. So if we plug in our x approaching 0 once again, we're going to end up with negative 1 on top and 6 on the bottom. Therefore, our result will be negative 1 over 6. And our multiple choice answer is going to be B. So that brings us to the end of this section. This was just a quick little review on how to use L'Hopital's rule when a limit gives you a result that is indeterminate, so either 0 over 0 or infinity over infinity. So I hope that you found it useful so you can apply it if you see a problem like this on your FE exam. In the next section, we're going to be covering some applications of derivatives. So that's going to include finding some critical points of a function and finding the minimum and maximum value of a function as well. So when you're ready, we'll see you in the next section.